Alright, so let's talk about graphing equations of the form y equals mx plus b. Incidentally, this right here, y equals mx plus b, is called the slope-intercept form of an equation. Okay, so you might want to take some notes on this page, hit pause, write some things down, and then I will show you what this page means on the next page. Okay, so the question here is 2, 1 a solution of y equals 3x minus 5? Well, there's only one way to find out. We're going to put 2 in for x, and we're going to put 1 in for y into this equation. We're going to see if it creates a true statement. If it creates a true statement, then it is a solution. If it creates a false statement, that means that it is not a solution. So let's find out. So for y, I'm going to put in 1. For x, I'm going to put in 2. Because remember, this was x, this was y. So I've got 1. Is that equal to, I'm going to put a question mark above that, 3 times 2 minus 5. So I've got 1. Is that equal to, 3 times 2 is 6. 6 minus 5 is 1. So 1 does equal 1. So I would say yes. 2, 1 is a solution. So with a linear equation, there's actually an infinite number of solutions. So just because I came up with yes here doesn't mean that this has to be a no. Number 2 has to be a no, okay? So you have to try it out as well. So we're going to put x in, or 4 in for x, we're going to put 9 in for y, and we're going to see if that creates a true statement. So I've got 9, is that equal to 3 times 4 minus 5? Is 9 equal to, 3 times 4 is 12, 12 minus 5 is 7. Those are not equal to each other. So on this one, I would say no. Okay, again, this is the solution page from the textbook, so you might want to hit pause. I'll give you a few seconds to take a look at it, but it's basically saying the exact same thing that I said on the last page. Okay, again, you might want to take some notes on this. They're talking about the graph of an equation is the set of points that actually the solutions lie on the line. If it's not a solution, it does not lie on the line of the graph. So any point that is a solution of the equation must be on the graph. That's number 1. Any point on the graph must be a solution of the equation. So it's just kind of the opposite, the reverse of that. Okay, so on this problem right here, find 5 solutions of y equals 2x minus 1 and plot them in the same coordinate system. Okay, so check this out. I can come up with 5, but I just want you to realize that there are an infinite number. And my 5 may not be the same as your 5. I try to come up with the easiest numbers possible that make the math simple. And my version of simple may be different than your version of simple. So you get to pick whatever values you want to pick. But these are my values. Now, the thing is, no matter what values we pick, if we were to put our lines on the same graph, if you were to extend your line, then our lines should sit on top of each other. So anyways, that's what I'm saying about there being an infinite number of solutions. So let's pick 5 numbers. So here's what I'm going to do. I'm going to pick a few negatives, I'm going to pick a couple of positives, and I'm always going to pick 0 because that makes my life a lot easier. So I'm going to try these 5. -2, -1, 0, 1, and 2. Those are 5 numbers that I just pulled them out of the air. So now I'm going to put -2 wherever I see x. So y is equal to 2 times -2 minus 1. 2 times -2 is -4. Negative 4 minus 1 is negative 5. So we have an ordered pair at negative 2, negative 5. Now I'm going to try negative 1. So y is equal to 2 times negative 1 minus 1. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So we have an ordered pair at negative 1, negative 3. 0 is always my favorite. Y is equal to 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is negative 1. 0, negative 1. Now I'm going to try 1. Y is equal to 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. Now I'm going to try 2. 2 times 2 is 4. 4 minus 1 is 3. So I've got an ordered pair at 2, 3. Now, then it says plot them in the same coordinate system. So let me grab a graph real quick, and we'll plot them and we'll see what happens. Okay, so here's my graph. Here's my x-axis. Oops, hang on. Let's do this. Here's my x-axis. Here's my y-axis. And I am going to label just every other one. Here's 2, here's 4, here's 6, 2, 4, 6, negative 2, negative 4, negative 6. Okay, so now whenever I plot these points, let me change colors here. Whenever I plot these points, you're going to see that they line up in a line. Negative 2, negative 5, negative 2, negative 5 is down here. Negative 1, negative 3 is right here. 0, negative 1 is right here. 1, 1 is right here. 2, 3 is right here. Now look at that. If I were to connect my dots, here I go, I'm getting a straight edge here, and I'm going to connect my dots. And don't forget to draw your arrows at the end. That is that line. That's how you plot an equation or graph an equation. That's one way to graph an equation. Alright, so let's move on. So here's the textbook solution page. Here's 3 of the solutions that they found. You'll notice that there's 3 of the same solutions that we found. And here's the exact same table that we created. We could have created a different table with different numbers for x and gotten out different numbers for y, but our lines would have still sat right on top of each other. Notice this graph looks an awful lot like our graph. They need to connect their dots. They need to draw the arrows on the ends. Alright, so the graph of an equation of the form y equals mx plus b. M and b are constants. Remember, constant's a fancy word for number. And that is a line. Okay, so on this problem right here, it says sketch the graph of y equals negative 2x plus 3. Also, find the y-intercept. So if you're finding the y-intercept, that is, let me grab a graph real quick, hold on. Okay, so here's my x-axis, right here, and here's my y-axis. If I am looking for the y-intercept, that means that I'm looking for where the line crosses the y-axis. So here's your y-axis right here, that vertical line right down the middle. And I want to know where the line crosses it, but think about what your x value is on the y-axis. Your x value is equal to 0 there. So whenever you let x equal 0, you are actually finding the y-intercept. So if I want to sketch this graph, okay, I'm not going to do as big of a graph as big as of a chart as I did last time. I am going to do, let's say, 0, 1, and 2. Again, just pull these numbers out of the air. This one right here is my y-intercept. Now, how do I know that? Because x is 0. When x is 0, you are finding your y-intercept. So whenever I put 0 into this problem for x, y is equal to negative 2 times 0 plus 3. Negative 2 times 0 is 0. 0 plus 3 is 3. So I have an ordered pair at 0, 3. 0, 1, 2, 3. Go up here and put a dot. Okay, so if I put in 1 where I see x, so y is equal to negative 2 times 1 plus 3. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. So I have an ordered pair at 1, 1. Now if I plug in 2, so y is equal to negative 2 times 2 plus 3. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. So I have an ordered pair at 2, negative 1. Okay, look at that. Those lines, or those dots, line up in a straight line. Draw your arrows on the end. Now we have sketched the graph of y equals negative 2x plus 3. Y equals negative 2x plus 3. That's that graph of that line. They want you to find the y-intercept, and the y-intercept is right here at 0, 3. 0, 3. Might want to hit pause here so that you can read through this page. Okay, so this page, it looks a little wordy, but let me explain what's happening here. Okay, so anytime you have an equation of the form y equals mx plus b, then what you're actually looking at, you are looking at the slope and the y-intercept. So in this problem right here, y equals 3/2 x minus 2. Your y-intercept is negative 2, so 0, negative 2. And your slope is actually the number that's in front of the x, so our slope is 3 over 2. So this is telling you that whenever it's in this form, your y-intercept is that right there. And you can write it as an ordered pair as 0, b. Okay, so let's look at this. We want to sketch the graph of y equals 3/2 x minus 2. Okay, so just like we said earlier, y is equal to 3/2 x minus 2. So your y-intercept is negative 2, so we have an ordered pair at 0, negative 2. Your slope is the number that's in front of the x, so our slope, or our m, is 3 over 2. That means up 3, right 2. So let's take a look at this. 0, negative 2 is right here on our y-axis. From that dot, from your y-intercept, you want to graph your slope. So I'm going to go up 3, 1, 2, 3, to the right 2, and put another dot. Just so you know, up 3, right 2 is the same thing as negative 3 over negative 2, because a negative over a negative will cancel itself out. So that's the same as down 3, left 2. So from my y-intercept, I can go down 3, left 2. See how those dots line up? Now I can connect my dots, draw my arrows at the end, and there's my line. And have I found my y-intercept? I sure have. It's right there at 0, negative 2. Okay, so the rule of 4 is you have an equation. That's rule number 1. You can write something as an equation. You can create a table. You can graph it. And you can verbally discuss it in words. Okay, so on this problem right here, it says, let's list some solutions of y equals 4x by using a table. Alright, so let's create a table. And I'm going to be picking out values for x. So let's start with 0. 0, 1, or 2. So I'm going to put in 0 for x. So y is equal to 4 times 0. 4 times 0 is 0. So now I'm going to put in 1 for x. Y is equal to 4 times 1, which is 4. Now I'm going to put in 2 for x, which is 8. Okay, so there's my table. Now I want to describe the solutions by using a graph. So let me get a graph here. Okay, so now let's graph this. 0, 0 is right here in the middle. Hang on just a second. Let me make that a little bit bigger. Okay, 0, 0 is right here. 1, 4, right 1, up 4 is right here. 2, 8, it's up here on the edge. So, let me... Okay, so now if we were going to describe this in words, this says that my y-intercept is at 0, 0. So part 3, y-intercept is at 0, 0. From the y-intercept, you go up 4, right 1. They use different points than I used. That's okay. It should still lie on the same line. So let's take a look. Look at that. It does. The only thing, they don't have 2, 8 because it would have fallen off of their graph. They put in -1 instead. But our lines would still sit on top of each other. Okay, and then this one they described it a little bit different than me. For each solution, the y-coordinate is 4 times the x-coordinate. I like their explanation too. Okay, I hope this helps you out. Have a good day.